For question 8, we're left with another proof question. Prove 1 plus cos x over 1 minus cos x equals to cosec x plus cot x squared. You need to prove one side to the other, and I would say go from right hand side to left hand side. The reason is because the use of cosec x and cot x means we can change these into different expressions. It gives us more wiggle room. We can change these using our identities of 1 over sine x equals to cos x and cot x equals to cos x over sine x. So now what we're going to have is 1 over sine x plus cos x over sine x. So now you can see the denominators are the same. So you're going to have 1 plus, should have all squared, 1 plus cos x over sine x all squared, which is now 1 plus cos x squared over sine squared x. Because cos x is at the top, the smart thing would be to change this into a cos x expression too. So use our knowledge of sine squared x equals to 1 minus cos squared x. And that should give you 1 plus cos x squared over 1 minus cos squared x. What you could potentially realize now at this point is there could be some cancelling out to do. We need to somehow get 1 plus cos x. This is the same as 1 plus cos x. 1 plus cos x over 1 minus cos squared x. We need to somehow get 1 plus cos x into the bottom here. And the way we would do that is recognize the difference of two squares. And that would make it 1 plus cos x, 1 plus cos x. Then the bottom would become 1 minus cos x and 1 plus cos x. The way we would recognize this difference of two squares is imagine you had x squared minus 9. When you're doing difference of two squares, this has to be a square number. This has to be minus, and this has to be a square number. If these three features are there, then you can do difference of two squares. When you look here, this is a square number, as it can be square rooted to 1. This is minus, and this is also a square expression, as you can square root this into cos x. And then thus, as over here, you would change this to x minus 3, x plus 3. You would change this to 1 minus cos x and 1 plus cos x. That's basically square root of 9, which is 3, and then you have minus 3 and plus 3. It's the same for every form. Once you have it in this form, you can cancel out 1 plus cos x from top and bottom. Then you're left with 1 plus cos x at the top and 1 minus cos x on the bottom, and that's what they wanted us to get.